Welcome everyone. I hope you all are doing your best. In today's lecture, we will be solving chapter 2, force vector, fundamental problem number 2. In last lecture, we solved the problem number 1, in which we found the value of the resultant force and its direction by using the force resolution method. Means we resolved each force into its component and then we found the value of the resultant force. So in this lecture, it is a bit different. We will be using cosine law to find the value of the magnitude of the resultant force. So far we know about how to solve this type of question by using resolution of forces method. So in this lecture, we will be learning a new method by using cosine law. Without further delay, let's get started. So in this problem, we have a hook and two forces are acting on the hook, and we have this force. I am naming this force as F1, and another force is 500 Newton, and I am naming it as F2. This force, the F1 force, is acting clockwise 30° from this axis, and this force is means F2 force is acting at a 40 angle in clockwise direction from F1 force, and it is this force means F2 is acting from this axis at a 70° clockwise direction. So we'll be determining the resultant force, that will be the resultant force acting. So we have two forces. So by using parallelogram law, we can know the resultant force will acting somewhere here. So this will be the resultant force. We'll be finding the magnitude of that resultant force. So now I am constructing the parallelogram. So then just applying the cosine law, we can determine the value of the resultant force. So here I will be drawing by ruler the parallelogram with the help of these two forces. Here you can see that I have drawn this force 500 Newton parallel force and from this point, and I will be meeting. Now I will be drawing the 200 force parallel. So you should keep in mind that it should be parallel. So with accuracy, then you can be able to draw the correct parallelogram. So now we have this force equal to, means this is F2 and this is F1. So the parallel component, the parallel force as it is, this is also F1, and this is parallel to this force. So this is F2. So now this rectangle will give the resultant force. This is parallelogram law, that it is like four-sided parallelogram, and this angle between two forces is 40. So by dividing by 2, so at 20° from this side or this side, we will draw a rectangle, a diagonal, and this diagonal will yields the value of the resultant force. This is the resultant force, and I am considering it as F, or you can also assume it R. So now we have two forces, F1, F2, and we have drawn the parallelogram, and this diagonal will yield the resultant force. Now considering this triangle, means considering this triangle, I'll be showing this one. This is the diagonal, and this is one side and this is the other side. Means considering looking at this triangle, we have this F2 force, and we have the F1 force, and we have the resultant force, and we have this angle, and this angle. So now what the parallelogram or cosine law says, that the resultant force should be equal to the square root of square of F1 square of F2 force, then minus 2 F1 times F2 times cos theta. Now you should remember that we know that we have F1, F2, and we don't know about the theta. So what will be theta? Whether this angle, or this angle. So you should remember that we will be finding the resultant force. So whenever you will be finding the resultant force by cosine law, so you should know that, and always remember that this angle will be the opposite of this resultant force. Means the theta should be this. This is my resultant force, and the angle opposite to the resultant force is this in my case here in this question. So this will be the theta. So before moving to the solution of the question, we will be finding this theta, because other things F1, F2 we already know. So only one thing we should know, theta, then we'll keep directly into the formula, we'll get the value of the resultant force. So this theta will be equal to, remember this, we have this 40 angle, means angle between these two forces, we have 40. So the diagonal will divide this force into two components. So means into two. So this force will be, means from the resultant force to this force, the angle will be 40 divided by 2, it will be 20. And from this resultant force to this force, the angle will also equal to this angle 40 divided by 2, so it will be 20 degree. So means from resultant and to the force F1 we have what angle? 20. So here it will be also 20. I hope you get this concept, that from where you can we can get this 20. So here from this resultant to the F1 force, we have this F1 and we have this resultant. The angle is 20, so here it will also be equal to 20 degree. So now we have this triangle. You can see that I will be trying just this triangle. So we have this resultant force, we have this F2 force, and we have this F1 force. Mean we have this F1, we have this F2, and we have this resultant force. I draw this triangle here. I just draw here this triangle F2. This is F2. This side is F1. And now I'll be determining that I know that this angle is 20 degree. And this angle is also 20 degree. In a triangle, we know that the sum of all angle will be equal to 180 degrees. So I am assuming that this angle is theta. So theta less 20, this 20 plus this 20 will be equal to 180. This is, we know that from the basic geometry. So theta will be equal to 180 degree minus 40 degree. So theta will become equal to 140 degree. So instead of theta, we'll be using 1. So this will be 140 degree. Remember this. So we have all values. Just put in this formula. We will get the value of the resultant force. See, this is the very basic as compared to the resolution method. So in this, we will only be facing the problem of this theta. So by simple geometry, you can easily find the value of the theta. So this resultant force will equal to square root of, we have the value, putting the value of F1 is 200 square less F2 value is 500 Newton square minus 2 into 200 into 500 into cos 140 degree. So putting all the values in the calculator, we can get the value of the resultant force, and it will become equal to, so it will become equal to 666. What will be the unit of the force? Here they are using Newton, so the value will be in Newton. So this is the answer of this magnitude of the resultant force.